Alright, so now we're going to go over converting our point cloud, which we generated in the last video, into our final STL mesh, or at least attempt to do so. So to begin with, again, we have the point cloud from last time, which is just our 4 scans of the 4 sides of Testudo, with a little bit of manipulating in order to put them in the right places and get all the points in order. Now, all we've done here is add a few lines at the end in order to export first the final cloud of the entire Testudo scan, minus of course all the bad points, and another 4, just for troubleshooting, to export the 4 sides individually. Now, just a bit above here, something that I ran into earlier with MeshLab, an issue is that MeshLab really does not like nans, or nada numbers, which in this case we've used extensively. So the way that I got rid of all of the excess data points in the mesh, or in the point cloud, all the useless data points, was to convert everything outside our range to a nan. The problem with that is that MeshLab does not like nans. So any point with a nan caused an error. There were about 30,000 errors, and it refused to import the cloud. So these are just eliminating any row containing a nan. So if any row in any of the vectors contains, or any of the matrices, any row contains a nan at all, the entire row is eliminated. And then the clouds after that modification are exported. So these will actually be imported by MeshLab. So we'll move on over to MeshLab now, where I've already gone ahead and imported the Testudo scan. Now here's the front of Testudo. On the back you can see that it's a lot easier to visualize Testudo in MeshLab than it is in MATLAB. However, in terms of actually processing the mesh, I've run into a couple issues, which include that the surface reconstruction by Poisson for some reason is missing from my edition of MeshLab. This occurred after a significant error when I tried to process all 4 sides individually. The option has been missing since then. I do not know where it went. So I exported the whole point cloud over to my desktop computer, where I processed the point cloud again and then brought it back. Now I couldn't process it over there in 4 sides because that crashed my desktop as well, but I could process the whole thing as a single point cloud. The only trick with that is that the single point cloud does not like aligning all of its points, all the normals of its points in the same direction. Now the reason for that is that this front face did not have post-processing on its data as opposed to the other 3 sides, and you can see very clearly the definition what that causes. So the post-processing of the images in terms of amplification of colors, while it does give better returns off of surfaces that are hard to read, it also causes significant signal noise, though only in the area immediately around the points. So what that causes is the lines, as you can see here, get a little fuzzy on any of the images that were post-processed through the color modification, and that didn't occur on the front face. So this front face gets normal vectors which are routinely the exact opposite of all the other surfaces. The issue that causes will be apparent in just a moment when we open the actual mesh of Testudo. That's not the right one. So the complication that this has caused is that the surface normal causes this little separation in the mesh right there. It's convinced that the first off, because of that noise, all of the normal vectors for all the sides point inwards, and any number between 1 and 100, and then random numbers between 100 and 1,500 don't seem to change that in a uniform manner. The only way to get them uniform is to have them pointing inwards, regardless of whether you reverse the orientation based on viewpoint. And the same is true in the opposite direction for the front face. So this is how the mesh has turned out. Now, if you discount this one glaring problem with the mesh, it does actually look relatively like Testudo. You get the hump in there. Now, of course, if it were possible to get the mesh with all the normals pointing in the right direction, it would most likely render a lot more accurately. But in this case, unfortunately, that isn't the case.